This video will cover how to do a chi-square test of independence in R, which is basically a test that we use when we have two variables, usually that are nominal or ordinal, and we want to do a formal test of statistical significance of their similarities or differences. The data that I'm going to be using in this tutorial, just like always, is the 2016 wave of the General Social Survey, which is freely available online. So what I'm going to be doing here is first building a contingency table, a bivariate table between the variables happy and sex, where happy is the respondent's level of happiness and sex is their sex. So the first thing that I'll do is just take a quick look at the variables just to make sure that all is well there. So you can see happy is fine. It has three categories and everything looks just totally normal. Then we'll do the distribution for sex. And here, if we take a look, we can just see it's dichotomous, men or women. So the convention for R, as I've mentioned in a few other videos, is that when we build bivariate table commands, it is Y and then X. So dependent variable first and then independent variable second. And so here our dependent variable is happiness level, GSS $happy, and our independent variable is sex. So just GSS $sex, and you can run it and then you get your bivariate table, just like that. In order to use the chi-square test, what we're actually going to do is just create a table object. So I'm going to call it happy tab gets the result of this contingency table, right? So you can see in my global environment, I have a new object popping up that's of the table class. And then if I wanted to just take another look at it to see what the frequency distributions, the contingent ones look like, it's just right there. Once you've done that, really that's everything that you need in order to specify the chi-square test. The major command for that is chi-square sq.test, and you want to pass that the table object that you've made. And then the only other thing to really keep in mind is what to do with Yates correction for continuity, which depending on how you're learning this material, you might want to toggle on or off. My preference in the way that I work with these, assuming that my table has enough cases, which is almost always true for the sort of data that I work with, I just turn that off. So I would type correct equals false. If you happen to know what Yates correction is and think that you need it, then you would put true instead. But my default, like I said, will be false. And that's all that you need in order to run the test. So if you do it, you can see that we get a chi-squared value of 1.1409 at 2 degrees of freedom. If you wanted to assess the statistical significance of this result, you could compare your p-value. Here it's 0.5653 to an alpha of something like 0.05 or 0.01. And so in this case, you could see that this test is actually not statistically significantly different. So for us then, it's a 95% confidence or an alpha of 0.05. Our p-value is bigger, and our conclusion would then be that men and women appear to be independent when it comes to their level of happiness. So there doesn't seem to be a strong pattern by sex in terms of one sex being happier than the other or anything like that. That's really the basics of how to do these tests in R. However, there's one other thing that I think is worth showing you in this tutorial because it will sometimes happen if you're working with sparse data. And so what I'm going to do is just create just some empty kind of variables of just junk just to show you how this works. So I'm creating one called X that's going to have the values of 1, 1, 1, 2, 2, and 3. And then I'm going to create a Y that'll have 2, 2, 2, 2, 2, 2, let's say, and then 1 and 1. And so if I just load those into R, you can see that I have them now showing up in my global environment, and I'm going to create a frequency distribution of the two as a bivariate table just to show you, so Y and X. And so you can see that I have a couple of 0 cells showing up there, and not really very many of these values are sparsely populated. And this will actually make a pretty meaningful difference for your chi-square test, because if I were to say make a table object called sparse table or something like that, that I would assign here, and then I would pass that to the chi-square command, and then sparse table, and then just like always, I'll just turn the correction for continuity off, And you can see that this is going to produce a warning message for me that the chi-squared approximation may be incorrect. And so if you're running one of these tests in practice, that's something that you need to be very attentive to, because the chi-square distribution is asymptotically true. So it's only true after you hit a certain sample threshold, which is generally undefined in practice. If you see this, that means that your test is somehow not in very good shape and is probably broken. So you really want to reconsider what it is that you're doing and very carefully interpret the results if that's something that you're going to do. There are some options that might help with that inside the help file for the chi-square test command, but that's really beyond the scope of what I'm going to do in this video. But really, that's all that you need to be attentive to. Otherwise, these tests are pretty robust and they're pretty straightforward and they're relatively easy to interpret.